If you've heard about Neuralink, then you know what Elon Musk is up to. With those robots and those chips that are planned to be inserted into our brains, there's a bit of a controversy around this field. As they push forward the idea of technology being integrated into men, we often wonder if this really is the right direction. Today, we'll discover more about the company and the upcoming trials. If this topic interests you, leave a like and subscribe to our channel so you won't miss a single video. And with that, let's begin. Way back in 2016, Neuralink was founded. As it gained a lot of popularity and media attention, the company continued amidst controversies. To add, Elon Musk was the man behind this project. He is the current Tesla CEO and SpaceX CEO. With his enormous pool of resources, he also spends time in his specific field in science. However, this was favorable for the press to create some intriguing stories about the company. The news lit up with stories about how Musk intended to put implants in people's brains. Others believe that this would cure all diseases and make you smarter. In exchange, you'll be a semi-cyborg that is controlled by a computer. Then again, the real reason behind the Neuralink was to express the importance and capabilities of humans. This new technology allows you to control your computer through your mind. It is not telekinesis since you can't move physical things. However, it can be virtual telekinesis. Imagine you scrolling through your daily emails without having to hold your phone. You can even send one without needing to type it in. This is all possible with Neuralink, or so says the company's vision. With our brains integrating with artificial intelligence, it allows us to become a human-machine hybrid. Technically, these are just the type coming from the media, but in reality, there are a lot of possibilities that the company has to offer. To note, Elon Musk didn't invent the brain-computer interface, for it has been around for quite some time. Despite this long overdue vision, the main problem was that there was zero progress in this field from the period between the year 2016 and the mid-90s. Everyone just thought it best to leave it in the sci-fi movies. Additionally, tests on humans and animals have ethical implications and a lot of people like to go against them. Despite this, Neuralink still comes in with its modern approach to existing technology. So let's take a look at the actual concept of the company. The idea behind the creation of a brain-computer interface is pretty simple. To note, your brain is an organ that controls the rest of your body. It is important because any missing or dysfunctional pieces would lead to overall negative impacts. You might not be able to write properly. You might not be able to move your fingers. You might not even feel or move your whole hand. As such, the brain is an important organ. It controls your motor functions by generating specific electrical signals. It would fire them out through your nerves and then into your organs. With electrical pulses, your muscles begin to move. But isn't this process quite familiar? Have you maybe seen this occur in another field? Well, this process is significantly similar to a programming language. With internal codes being sent throughout the human body, your brain is sending command prompts. The pathway of these commands goes through your spinal cord. However, there are misfortunes and accidents. Not everyone is lucky enough to come out whole, and sometimes that connection between the brain and the body gets cut off. This could either occur in part or entirety. It can also be caused by a degenerative disease. Keeping this in mind, the BCI can actually function like a bridge. This is especially true for those electrical signals that would need to bypass the broken connections. And this is what makes Neuralink's product interesting. It can help people, especially those that need it most. The philosophy of the BCI can be divided into two. The first one is that it's invasive, and the second one is that it's non-invasive. The non-invasive BCIs are those weird hats with tons of electrode sensors all over. It is basically a brain cap like that of Professor X in X-Men. Through this piece of machine, it has the capacity to read the electrical signals from the brain. The only downside with this technology is that it has a hard time reading the signal through your thick skull, literally. The entire skull serves as a barrier between the sensors and the neurons, so it reduces its overall efficiency. So the second option is the invasive one, wherein they cut out a chunk of your skull, and after that, they will attach a miniature computing device directly on top of your head. This is then connected to the Utah array to the giant wires. They have to do this twice, each one for the left and the right. Not everyone would be happy to see wires coming out on top of their heads. However, this method is very effective. With this brain implant, humans are now able to control electronic devices with only their brains. For example, they can control a robotic limb, and another example could be that they can control a mouse or a keyboard with only their minds. As the internal signals are easily read, the process isn't really compatible with prolonged use. With a bunch of tiny nails being attached to the surface of your brain, the body's initial response is that it's a foreign object that needs to be rejected. That part of the brain might get inflamed or form a scar tissue around the puncture. Eventually, the device will have no more use. So, how does Neuralink intend to overcome this problem? With the next generation of BCI technology, everything's about to change. This new gen is currently being led by Neuralink and Synchron, both of which are startup companies. Synchron is the first to reach full human trials. The first group that they tested in Australia was for patients receiving implants. And this is when they discovered that the country barely has regulations about what you can put into people's brains. And in the last year, the FDA provided a go signal for Synchron to begin human testing in the USA. The first patient just received their stentrode implant. This person will be the first of 6 people involved in the $10 million study funded by the National Institutes of Health. Isn't that impressive? To understand why this company went ahead with Neuralink, you can look at their methods. You see, Synchron uses a different design for their implant called the stentrode. This implant is named after a common medical device, a stent. This device is a long, thin, flexible tube that doctors can insert into a patient's blood vessel. With stents being used in several procedures, why not also make them be used on the brain? And with this device, Synchron helps people to be able to use computers and communicate through text. They can do this just by thinking. Cool, right? However, it also has its disadvantages. The device is only inside a blood vessel that runs through the brain, and the electrode is not actually inside the cortex tissue. Rather, the signal is coming through the stent road. It is physically limited, and so it can't match the bandwidth of the Utah array. In other words, the company is solving problems but not in its entirety. And this is where Neuralink comes to the rescue. So how did it make a difference? The Link device brings together both the traditional Utah array and the modern stentrode. This allows them to take the capability to an even higher level. Additionally, the Neuralink does require the removal of some skull material. However, you're gonna have another hole on your head, but this time it is done by a robotic sewing machine so as to carefully insert incredibly fine and flexible electrode wires into the outer cortex layer. This is done with extreme precision, and they go in a couple of millimeters. The robot is then allowed to place the electrode directly into the neuron that they want to read. This method allows it to have a source of maximum bandwidth. With each of the links, the device has about 1,000 tiny wires, so you can be sure that there is an incredible amount of signal coming through. So, what do you think about Neuralink? Do you like its methods of integrating the brain into technology? Or do you like the method from Synchron? Leave a comment down below. And before you go, please hit the subscribe button. We still have a lot to discuss about the Neuralink, so be sure to tune in into the next uploads. This is Markiplier, and I'll see you in the next episode.